Thank you. Hello, everyone. Me again. Welcome. Welcome to this tech commercial from Castel. I'm joined here today by Alessandro Farina, who will be telling us more about their way of designing. He's one of the application managers at Castel, who trained as a mechanical engineer, has 22 years of background in research and development. So he knows what he's talking about. He also does project management, testing planners, and creating all of that. He has elaborated background in. He's also a high-level trainer, a problem solver, and yeah, he's the technical contact for North and South American market and Canada, and a key technician manager for the relationship with OEM systems builders. It's quite a mouthful. You sound like you're definitely the right person for this conversation. But before I hand over to you, you guys all know the drill. If you've got questions, you know the live discussion tab at the bottom, send them through, and then we'll take them at the end. But in the meantime, Alessandro, the floor is yours. Tell us a bit more about how you guys design.
Okay, thank you. I have a good morning to everyone. This is my first presentation here in atmosphere. If I have a long visiting all the atmosphere among the world. This is the following presentation is about a new way of design, a new way of projecting of Castel. Okay, who is Castel? Castel is a long-term factory that work with the component. Maybe a lot of people in the market know us. We start to make components for natural gas for HFC more than 60 years ago, and we are starting to work with CO2 in about 10 years ago. During this year, we are increasing our portfolio, we are increasing our family, and we are open all around the world. What we are going to speaking in this presentation, in all the market, there is the necessity to reduce the time to market of the component and to go this in the least impactful way possible. The way to do that can be to test everything, every goods, every component with using all available natural resources without thinking of what we leave for the future for our goods. We can follow this path, always keeping in mind not to go out of the way of the new design. We must stay on focus on environment. In order to do that, we need some skill in engineering, some new skill in information. We need to understand how to be critically, how to increase our capacity analysis of the problem. Consider that we test all of our components, and we have done a very big laboratory area. Imagine that we occupy a lot of space in our laboratory area, a lot of space and a lot of money. We have a plant that then can test the capacity of the safety valve, which work with high pressure nitrogen, and we have to make this high pressure nitrogen, or we can make the calculation of the capacity of the expansion valve, and we have to do that with all the refrigerants in commerce. And after that, we have to waste all the refrigerant we use in that testing. Imagine how many time, how many waste, how many impact on the environment can be this energetic creation and this waste of maybe sometimes also with this IGVP refrigerant. For that reason, some years ago, we have chosen to introduce the simulation of any impactful test in our lab. We have started the collaboration with the Polytechnic of Milano in order to increase the skill of our engineer in order to simulate the reality, because it's not so simple to replicate the physical test. You have to be sure that the virtualization of the reality must be the most real possible. We have starting from the more simple test in order to have a feedback on the theoretical result with the experimental result, and we have made this with the collaboration of the Polytechnico. In this year, able us to expand the virtual test process even on the experiments that are not economically realizable from in the real. Imagine a very big valve, a very it's difficult to explain how is how is hard to test a very big component in a very big in a very big circuit for a small component factory like us. Can be very hard for us. And when we have done these two, when we have chosen to virtualization or make a big part of our testing laboratory, we have decided to give a weight of this wasting. Imagine that we carry about 400 reports in 1 year, and these about 2,000 on different sample. This involves tons of waste, tons of CO2 equivalent waste coming direct or indirect electricity consumption, environment pollution. In this addition, we have to compare whether the tons of CO2 equivalent waste as much as the value of the physical experiments performed. To do that, Castel has decided to carry out a study of life cycle assessment in order to determine the carbon footprint of the test of a big number of our products. And we make this with the Polytechnic of Milan. We have performed this studying according to the actual standards that you see in the slide. Okay. Well, in order to define the carbon footprint, as I know, we must to go through the life cycle assessment. What is the life cycle assessment? I try to make a fast explanation about this life cycle assessment. Is is a way to identify the process involved in the life cycle. In all the story of the product have an impact, starting from the inventory, following by the impact assessment, and also through the packaging, the maintenance, by the disposal. We have performed this study on a huge number of components, starting from the raw material, movement, machining, and testing, and after we have made a summary of all of these weight in terms of carbon footprint. In this slide, I will explain only two particular components of Castel production. We are going to explain the carbon footprint of safety valve and the carbon footprint of expansion valve. And we have taken in consideration the analysis of the capacity and the behavior only in the most challenging test. We have considered the KD test, the KV test, the flow test, and the massive flow test for the expansion. Those are the value from the physical test. Those are the value of the carbon footprint analysis from the physical test of the safety valve. As you know, as you see, there's a 6 row of value. These 6 rows are depending on the different steps of creating the acidification and the eutrophication. The first two are strictly depend on the creation of the sample, because it's a pollution of the water. The GWP, the ODP, and the abiotic use of and the abiotic depletion are strictly related to the physical execution of the test due to electricity, gas wasting, and something else. You have to consider that in the physical test, we use at least 10 samples. We have to perform the same test on 10 samples. Also the POC, the POCP, the fifth row, it was inserted, but is a very little contribution, because it's the ability of volatile organic compounds in the air. It is related to the creation of energy, to the physical test, to the virtualization. Also, it is a common code like smoke. In the virtual test, you can see how the value is changing. You can see that the first, the second, and the last row are going to 0. Why? It's not only in the text execution, not in the sampling preparation. Why this value is going to 0? Because we have used only one test in the first time, not 10 tests like the physical one. We have used only one test in order to validate the methodology. This is why is 0. Also, if the KD test and the flow test can be in a very fast way in physical method, imagine that the physical method can occupy 3-4 hours. The virtualization made by calculation can be up to 14 hours. It's a very long, but the environmental impact is significantly different. It's very, very, very different. This is a resume of the value that you have seen in the slide before. As you see, the impact of a preparation of the sample is very high instead of the test execution. And in the imagine on the right, you can see how the physical test is more impacting in the real life than the virtual test. A value quite similar to the expansion valve, not the same, because in the expansion valve the value are quite higher, because in the expansion valve we use often a lot of refrigerant, a lot of the new refrigerant, and we have to consider also the impact of this new refrigerant inside our testing, and these values are quite higher. But also in that case, you can see that the text execution virtualized is about 0. The value is 0, because also in that case we have not to prepare any sample, because we have already prepared in the time when we validate the virtualization testing. The same, it's seem to be the same graph, but the value are quite different. But also in this case, the preparation of the sample as a very big aid. This is a summary of all the value. Imagine that we have reduced about 87% the carbon footprint of all of our testing. We are increasing this value here by here, because we have now the number of sample is 10% than in the past. It's only the necessary test, not the necessary physical sample. That means also in the reducing of cost. We have not a precise idea about the reduction of the cost. This is an estimation, because we have never made the costification of the testing or to preparing a sample. But now we do not use energy, we do not use sample. This could be a good indication. The next step of Castel is to expand this philosophy in all the process involved in the factory, the geothermal, the car, and we want to extend this calculation also to production. We want to see how the production of Castel can be impactful on the world, on the ambient. The virtualization approach to the design of component behavior contributes to reduce the impact of the carbon footprint in the prototype and testing phase. We are sure of that, and we will follow in that direction. Thank you for your time. I'm finished, I hope in time, and I'm here for your questions.
Thank you so much, Alessandro. That was It's exciting to see that you've already worked with natural refrigerants for 10 years and come up with some really good solutions. I think Castel is really setting a good example for the rest of the industry. We've got a few extra minutes just so we could fit in a question or two as well. I just wanted to ask, have you considered in your survey on the pollution impact of your components under testing, the contribution due to the use of gases with high global warming potential during the compatibility test?
Yes, consider that any chemically compatibility test on any component generate some loss of refrigerant. This loss was not be calculated because by the standards accepts this kind of loss. But imagine on about 1,000 on component mount and dismount, mount and dismount, and this charge in the ambient, these gases. This is a very high impactful, and we have considered that value in the expansion valve consideration.
Thanks, Alessandro. I think the time has caught up with us a bit there. But I mean, everyone
too fast.
You've done too many exciting things. But I think everyone can send you a question on the net. You are still on the platform if they have any more.
Okay. Thank you very much.
No, thank you so much for joining us.
Thank you for the time.
We're going to have a bit of a break now, and then everyone can come back for the end user panel starting after lunch at 1 o'clock. So